introduce multiple generative agents, interactive simulacra of human behavior. Multiple generative agents are simulacra of human behavior in interactive environment, which are dynamically conditioned on agent's experience and changing environment. Large language models in multiple generative agent architecture are used to power their behavior. 25 unique agents are in a community, including coffee, bar, park, school, dorm, houses, and stores, as shown here. One paragraph of natural language description is used to depict each agent's identity, including his occupation and relationship with other agents as the seed memory. Generative agents interact with the environment by taking actions and with each other through natural language. By interacting with each other, the generative agents in the community exchange information, form new relationships, and coordinate joint activities. Generative agents form new relationships over time and remember their interactions with other agents. Generative agents perceive their environment, and all perceptions are saved in the memory stream. Based on their perceptions, generative agents retrieve relevant memories and use the retrieved information to determine the future action. These retrieved memories are used to form longer-term plans and create higher-level reflections, both of which are entered into the memory stream for future use. Generative agents take the current environment and experience as an input and generate behavior as output. This memory stream, this retrieved memories, this action plan, and this experience reflection. Generative agents combine large language models with synthesis and retrieval of relevant information, and his core component is a memory stream that maintains a comprehensive record of agent experience. From the memory stream, the records are retrieved as the relevant information to plan the agent's actions and react appropriately to the environment. The records are recursively synthesized into higher level reflections that guide the agent's behavior. Generative agents implement a retrieval function that takes the agent's current situation as input and retains a subset of memory stream to pass on to the large language model. The retrieval score is determined by recency, importance, and relevance, which are computed by cosine similarity of the embedding vectors, as shown here. Reflection is the second type of memory, which contains a higher level abstract thoughts generated by an agent. The first step for generating agent reflection is to determine what to reflect on by identifying questions to be asked given the agent's recent experience. A large language model is queried with the most recent records in the agent's memory stream and prompted with the query information and the most silent high-level questions that can be answered about the subject in the statement. The large language model's response generates candidate questions. The generated questions are used as queries for retrieval and get relevant memories for each question. Then, prompting the large language model extracts insight and cites the particular records that are served as evidence for the insight, as shown here. This reflection, this experience. Generative agents We use large language models to plan over a longer time horizon to ensure that their sequence of actions is coherent and believable. Plans describe the agent's feature actions that keep the behavior consistent over time. A typical plan includes an action, a starting time, and duration. Plans are stored in the memory stream and used in the retrieval process. This allows the agents to consider observations, reflections, and plans all together when deciding the behavior. Generative agents may change their plans in midstream if needed. To create an initial plan, a large language model is populated with the agent summary description and a summary of his previous experience. The generative agent serves this plan in the memory stream and then recursively decomposes it to create a final grade actions. Generative agents operate in an action loop where at each time step, they perceive their environment and the perceived observations are stored in their memory stream. A large language model is prompted with observations to decide whether the generative agent should continue with his existing plan or react to other agents or his environment. For more details, please check with these references. Thank you. Bye.